Linkedlist. Share screen. Okay, here. Yeah. So what today we are going to discuss is we are going to continue the discussion about Linkedlist. But today we are going to discuss another, maybe we can call it improved way of the implementation of Linkedlist. And the major point today we are going to discuss is about iterable interface. It's also quite a useful concept. Okay, iterable interface and the iterator interface. And I'm not sure if you still remember previously, in previous units, we discussed, like we call it for each loop, the enhanced loop, the for each loop. It's kind of like a for, and there's some type, is it, and some variable, and then over here, it must be some kind of collections. And why you can do this is because the collections has implemented the iterable interface, okay? And the iterable interface, it has a function called iterator, and it will return an iterator. And with that iterator, then you can loop through. So why we can use a for each loop is because internally, the iterable interface is implemented by that specific collection. Okay, so that's a general idea. So let's take a look how all of that works. So we are going to continue our discussion about Linkedlist. And so today what we discuss is still our own version of Linkedlist. Most of the concept is similar as what we discussed last class, but we added some new features is regarding that iteration, okay, the iterable interface and the iterator. So let's take a look first. So the very beginning, I'm going to discuss that we also want our Linkedlist to be, when we have the implement the clone going to be the deep copy, okay? And also we are going to support the Linkedlist also be going to have some of our own class objects as kind of Linkedlist. And so the object is also going to be a deep copy. So it also has the clonable interface implemented. So in this case, we first define our own version of interface. We call it T clonable, okay? And this interface, it comes from the clonable interface. And clonable interface, we know that it has a function of clone, etc. So we needed to implement that clone method when we have our class implement a clonable interface, okay? And then let's see, I needed to close this first. Then let's take a look at the car class quickly. So for the car class, it's a very simple one, okay? And this car class also implements the clonable interface that we just defined, okay? So for this car class, it just has name and color, and we have constructor, and we also implement a clone one, okay? The clone method. And this clone method is a deep copy because we create a new car instance, is it? In heap, and we are going, but with the same name and the same color, is it, as the object car itself. And then we return this deep copy of our car. And for this function, we also implement the toString, override the toString method. We also override the equals method, okay? So the equals method just to make sure the name and the color all are equal. Then we can say, okay, both car objects are equal. So over here, this car class also implement the clone method, okay? And implement the clone method, it's because the car implement the clonable interface. Okay, so not a lot of new things here. Then let's take a look at the linked list. So for this linked list, let's first go to our linked list general structure. So for this linked list, if you take a look, it's a generic one, is it? And this generic one, this generic interface, this generic linked list, it must, the generic part must, whatever that object you're going to use for this linked list, it must implement the clonable interface that we just defined, okay? So that's part we learned. So this is bounded one, okay? This is bounded generic. So previously we learned the generics, is it? So this is bounded one, okay, means. And if we take another look, let me see. How do I, hold on, okay, I'm trying to, okay, try to move this here, okay. And for this linked list, it's a bounded generic linked list. And this linked list, if we take another look, you will find at the very end, we also said it's going to implement an iterable interface. Okay, so this is new. So this is an iterable interface. And this, so what is an iterable interface? Okay. So for an iterable interface, it must have, I need to close it. So an iterable interface, within that interface, it has a method called iterator. Okay, and that iterator method, if you implement the iterable interface, then you must implement this iterator method. And this iterator method, what is the return type is an iterator. And this iterator, basically, it's another interface. And later on, we are going to learn collection, Java collections. Okay, and then we will see, we will discuss more about iterable interface and iterator. Okay, so here let's just have a general idea. So anyway, that iterable interface is an interface, and it has one of the method called iterable. Okay, because it's interface, so that method is not implemented. And over here, so we are creating a linked list class. So this linked list is a class, and it's a concrete class. But of course, it's a generic one, okay? And because it's a concrete class, so all of the method must be implemented, etc. So because we implement iterable interface, so it's an interface. That interface has a method called iterator, and that iterator method not implemented in that iterable interface. So over here, we need to implement it. And that iterator method, what's the return type is an iterator. Okay, and that iterator, like I just said, it's another interface. Okay, so what that is? So let's take another look. And the iterator, as I just said, it's also an interface. Okay, it's an interface. So over here, we define a class, and this class will only be used by our linked list class. So we defined as a private one, okay, and within the linked list. So basically it's an inner class. So it's a class, and we call it linked list iterator. Okay, and what this linked list iterator is going to implement that iterator interface. This iterator is an interface, and this interface, what the iterator interface has is, whenever you implement that interface, there are 3 methods you need to implement. You need to override. They are not implemented. They are abstract method defined in the iterator interface. The first method is called has next. Okay, has next, make sure is, okay, after this iterator, there's something else. So it's called has next. And then it also has the method called next. So next method is just to check if there is something else after this iterator. And there is a third method called remove, okay? And you can also do something. So let's take a look here. So you may think of this kind of not make sense at this point, okay? So let's go back to take a look of a linked list. And linked list, last week we already learned, is it? So it's a collection of nodes connected together, is it? So here, and we suppose have 100, 200, something is there, and this one is the first node, is it? So in linked list, we only have this single instance variable, okay? This single instance variable called first, and the type is a node. As the last week we already learned, and a node has 2 parts, the data part and a next part. So this is data part, and the next part is a node again, is it? And it only has a constructor. So for this node class, quite simple. The constructor is to create a new node, is it? And also specify who the next is going to be. Okay, so this node we understand, is it? So then you may ask, what is an iterator? So in this, previously, you remember when we discussed linked list, we also mentioned a concept each time when you want to do traversing. When you want to do traversing, what do you need? You need a cursor, is it? And what is a cursor? A cursor basically is just a node, is it? So in this case, that's the cursor. Cursor is also a node, and it starts from where? Start at the first node, is it? Then it can advance, keep advancing, is it? So basically, what the cursor does is, it's kind of, it can remember where the current node is it? And then it can also advance to the next, is it? So here, it's iterator concept is something like the cursor in this sense, okay, over here in this scenario. So the iterator basically is just remember where you are currently, okay? So where it is, the position is where it is. And that's why you remember when we discussed the iterator, it has 3 methods, is it? It has a method called has next method, and the next method, and the remove method, is it? So that iterator interface, you need to implement these 3, is it? And now if you take a look, this has next, what it does. It says, okay, if you need to check this current node, if it has a next node, or if it's the last one, is it? If it's the last one. So that has next. What does the next mean? The next means, it means in this area, it gives you the next node. Okay, give you the next. And what does remove do? Okay, remove it means, okay, you're going to get rid of this node. Okay, but the linked list is still going to be a linked one, you still maintain the linked implementation. So this is the iterator concept in this linked list regarding, okay. So now you may have some idea about the iterator, okay. So over here, I also put it. So iterator, what does it do? It allows you to also remove later on, we're going to see, okay. And so iterator is what? It says it's an iterator over the collection. Like I just said, basically in this linked list scenario, it's just kind of like the cursor, okay? And you can use it to do the one by one node visit. So that's why we call it iterator, okay? So it's kind of like a position. We can call it a position tracker. You can kind of call it like that, is it? And in our linked list cases, like I just explained, is it's more like the cursor's role. And so that's just the basic definition for iterator. And then the iterable, is it? Iterable, it's also an interface. And the iterable interface, what does it do? Is it? It's because I explained the for each loop statement. Okay, so if any kind of data structure, if you want that data structure to support that for each loop, then you need to have your data structure implement the iterable interface, okay? But that's not the single use for iterable interface, okay? And the iterable supports the iterator, but with the iterator you can do then a lot of things. Later on we are also going to explain, okay? So that's the concept of iterable interface, okay, and the iterator concept. So our linked list basic building component is a node, we understand it. And in this version of linked list, this is a default constructor. So it's pretty simple. You just create an empty one, okay, nothing new. Is empty, it's similar. And here for our insert, this time the insert function is not going to do the insert in ascending order, okay? So this time is you specify certain item, then you are going to insert the new item after it. So the scenario is like this. So we have the linked list. Suppose it's this, is it you have 100, then 200, 300, 400, 500, 600. Suppose you said, okay, so the item in this case, suppose it's 300. And you said, I want to insert 350 after it, is it? So then 350 should be here. Is it should be here. Insert between 300 and 400, is it? So let's see, how do we do that, is it? And the first case is pretty simple, is it? So that means you have an empty one, is it? Your linked list, so that means first point to a null, is it? So then in this case, of course, you need to create the new node, is it? With whatever you have, is it? Then you create, you let your first node point to this single node. This is your linked list. So that's the first scenario, pretty simple. And then let's take a look. This time you first need to do it because you're going to insert after 300. So you first need to find this, need to locate this node. Locate node. Okay, 300 node. So how do we do that? Then in this case, we are going to use our cursor. Okay, the node by node visit, is it do the traversing, then you need to use a cursor. And we also have a precursor, okay. recorded here. And the last class, we also explained. And with cursor and precursor, then you can do pair advancing. Okay, so how do we do that is we're going to do shorter circuit while loop, is it? So cursor not equal to null first. And then you're going to check if you find the item, is it? With cursor's data, is it? So this part is regarding the cursor, so try to compare all of its data part, node's data part. And then the data anyway is some class. If there's some class, then you can call the echo method, is it? And then to find if you can find the item, okay. And if you find the item, then it's going to stop. Otherwise, it's going to advance to the next node. Is it? So this concept we already know, it's traversing. Okay, once you find it, is it? So in this case, once you find it, how I insert 350 between 300 and 400, is it? Then you set cursors next to this new item. So cursors next to 350, is it? To 350. And the 350 is next set to who? To cursors next, is it? So that's how we insert a node between two existing nodes, is it? But there is another case is in case your new item is going to be at the very back, is it? So suppose your item is going to be 650, is it? If it's 650, then what you're going to do? This is a precursor, is it? Because your cursor is null, is it? So this is a precursor. So precursors next, is it going to point to this new node? Is it? A new node is going, its next is going to be a null. Okay, so that's how this insert after works. A little bit different from what we discussed last week. Okay. And then let's see, over here it's remove. Is it to remove some item? Okay. And the remove item, I believe this is similar as what we discussed last time, okay, last weeks. So I don't think we needed to go over it again. And then next, let's see. Here we have another function. So basically this function is kind of like a search function. You want to find some item, is it? And if you take a look, oh, this contains, it doesn't do the traversing, is it? No traversing. But it uses what? It uses for each loop, is it? Instead it uses what? The for each loop. And why it can use this? That's because the iterable interface. Okay, that's because this linked list already implements the iterable interface. That's why over here you can use it. Okay, otherwise, like for the linked list that we discussed last week, you cannot do this loop. Okay, it won't support it. And then this is pretty simple. So, over here, this means what? This means the linked list itself, okay? Itself. And previously when we discussed a class, is it? So if we see the diagram, UML diagram, is it? So you have your instance variables and the instance method, is it? What does this mean? So it means the object itself, is it? So object itself, is it? So in this case, this means the linked list, okay? Okay, so it's going to loop through this linked list, is it? Then it's check if it can find that item. Is it if it find, it's going to return true. Otherwise, outside the loop, that means it doesn't find any of the items, so it's going to return false. Okay, so nothing new here also. And over here, we add another new method. We call it get, a get method. Is it? Well, this get method is it pass in an integer number. Is it? So this means, okay, you're going to find the first item or the second item or third item. Is it? So you give the specific location of the item that you want to find in this linked list. Is it? So let's see, how do we implement this? Is it? So we have this linked list. Okay, suppose 100, 200, 300, 400, 500, is it? We have this link. And over here, suppose your is 3, is it? So that means you're going to find the fourth one, is it? The fourth one. Over here, so how do we do it? And of course, if it's a empty one, then you just throw the index out of bound exception. Is it? Otherwise, we can start to do traversing. Is it? So cursor going to start from the first load. Is it? And then you're going to do the regular loop. Is it? For integer k from 0. Is it? Then do count. Is it? And how do we do the traversing? You just advance the cursor, is it? And you just basically kind of here do count, see how many times the cursor already advanced, is it? Until it reaches a certain number that you are looking for, is it? Then the cursor will be at that location, is it? And if the cursor is now definitely, that means, suppose in this case, you said, okay, cursor number position is 10, then of course your linked list only has 5 items. It won't find the last item, is it? It's going to be null. So that's why you can throw index out of bound, is it? Otherwise, what you can do is you can just return. That means in this case, we do find 400, is it? So what you can do is you just return a copy. Okay, so here we return a deep copy, is it, of the item. And why we want to do that is the encapsulation here, the concept. You want to hide your private information, is it? So that's what the get does. So basically this get function is just a traversing, partial traversing, okay? And the toString, it's similar as what we already discussed last class, but this time we use that for each loop, is it? Okay, then let's see another concept here. We also do the implement a version of check, the equal method. So what this equal method means, if you have 2 linked lists, okay. So this is 100, 200, 300, this a linked, and then you have another one. So here, be careful, okay. So we have two linked lists. Okay, this 2 linked list will be at 2 different memory locations. But you want to check if this 2 linked list, item by item, the data part of node, of each individual node, if they have the same contents. Is it? So that's what this equal means. You're going to do node by node check. Is it? So how do we do that? So of course, if the second linked list, you want to check if it's a null, then you return false, okay? And also you can check if the contents are the same information, is it the same type of class? If not, of course, you return false. And then next, let's see. What we are going to do is, okay, we are going to check, and here, be careful, this equal function method. The equal method, the parameter type is what? It's an object. It's not a linked list, is it? So that's why over here, the first thing you're going to do, so basically this is that other. The other initial over here, the type is that it's object, is it? And over here, you want to compare to linked, but itself, basically, when you plug in the argument, it's going to be linked list, is it? So that's why over here, you're going to cast the other, okay, to a linked list. Okay, it's a linked list. Then what I'm going to do is I'm going to have my cursor, is it? So this is the cursor. Cursor set on the second ones, is it? Then I'm going to loop through who? Loop through. So this is this. That this means the first linked list yourself, is it? Then you can check item by item, is it? How do I check? Because you can check. So this X is from each of the item, the linked list, is it? And you are going to, so over here, it's going to get the data part, is it? And you're going to check if it's the same as the cursor's data part, is it? You're going to do one by one check, and at the same time, you're going to advance your cursor. Okay. And if everything is right, is it? It's the same, then you are going to return true, is it? Otherwise, then you can return false. Okay, so that's the general check over here about this equal method. Okay, the next one, this is also interesting. Okay, so this time we have another method called copy list. What this copy list does is it return, if you take a look, a linked list. Okay, the linked list, so the concept over here is, okay, you have a linked list. We have this linked list, is it? So this is 100, 200 something, is it? 3, 4, 5, 600, is it? And what here I wanted to do is I wanted to create another deep copy. Okay, so over here, a deep copy of this list. This list is that this. Okay, is that this? Is it? Okay, so because you're going to return a linked list, is it? So that's why we call it the copy. So basically, that's the copy. Okay, you're going to create. So you're going to create another linked list. So how do we do it? So we're going to start from the first node, cursor. We start here, is it? And if it's an empty one, of course, the copy should also be empty. So that's why you just return now, is it? Otherwise, what you're going to do is the copies first. Be careful, okay? The copies first. So this is its first. Okay, its first is going to do what? You're going to create this new node, is it? You need to create. How do you create the new node? You're going to use that information. First is data, is it? And you want to create a deep copy. Because if you don't call clone, basically you're going to have whatever is here. So both lists will share the same information. But over here, I want to do a deep copy, is it? So you make a copy of it here. Okay, so that's why here you need to call the clone, is it? So you create the first node. Okay, and then for this one, because you're going to create a linked list, so that's why here you also need a cursor. So I call it the cursor, is it? And you also let it point to its first node. Okay, then you're going to start to loop the first linked list, this self, is it? Self. And you're going to move your cursor, is it? Advance your cursor to the next node. Okay, and with this newly linked list, you want to make the copy, is it? You need to copy what? To copy cursor's data, is it? So the cursor advances to the next node. Then you're going to get whatever information from that second node, is it, to this newly created. So you need to call new node, is it? And then you're also going to set to, you also needed to do what? You also needed to connect the previous node with this newly created node. Okay, so this is going to create a deep copy of the linked list. So you're going to do the data part one by one copy. Okay, so it's going to be a deep copy of the original linked list. Then you can return the copy. Okay, so this is a new method called the copy list. So it's going to create a deep copy. How do we do it? Is you need to loop through the first linked list, do the data part copy. Okay, so that's about the copy list. Now let's come back to our iterator. Okay, so we said the iterable interface. So iterable interface is quite simple. It only has two methods. One of it is called iterator. Okay, and over here we implement this iterator method. What it return an iterator. And over here it returns what? It says, okay, I'm going to return that new linked list iterator. And that new linked list iterator is what? Is a class I defined. Is it? It's an inner class. And that inner class that I define implements what? Implements iterator interface. And the iterator interface, it like I just said, has three methods you need to implement. You need to have the next. You need to have next method also implement. You also need to implement the remove method, is it? So let's see, because this is a class, so you need to have an instance variable. So in this regarding, because what we said is this iterator basically kind of like the cursor concept, is it? So that's why it's locator. That specific locator, the type is going to be a node. Okay, for this iterator. And what its constructor does, and then you just let this locator be start with your linked lists first. Okay, this first is your linked lists. Linked lists. Is it basically you can also write as what? As this dot first. What is this? This is that linked list, okay, object self. Okay, then we have the has next. So that's going to check if this is the last node, basically. It's a return Boolean, is it? Then what you can check is, you just check if this node is a null, is it? Because in the linked list, if it's a null, that means you already reached the end. Okay, that's a has next. And then we also have the next method, is it? The next method basically in this case, like I explained, is define how to advance, is it, to the next, is it? And it's going to return the data part, okay? So in this case, and then so it has next. So this is going to be the next node, is it? And it's going to return this part, the data part of your linked list, is it? And of course, if it doesn't have next, then you just throw some exception. So here is no such element exception. Otherwise, what you're going to do, you are going to have the data part be remembered by some variable, is it? And you're also going to do what? The next is also going to, so here is your next node. Next node. Is it kind of like our cursor, is it? And then you're going to advance it, is it? Because you're going to move it, is it? So you're going to advance it. So that's why how you advance, you just let it set it be its next node, is it? Then you can return whatever inside it, is it? So that's the next. Over here, the remove method, we didn't implement. Okay, we didn't implement the remove because we don't want to mess up because our linked list already has a remove method. The linked list already define a remove method. So for the iterator, then we don't want it to do it. Okay, now I believe you understand the concept of the iterable. Okay, so just remember iterable interface. If you want to implement, then you need to provide the iterator method. So you need to write your own version of iterator method. What it returns some iterator. Is it? In this case, it's return what the linked list iterator class that we defined. Because whenever you call this new one, it's going to do what? It's going to set your iterator to what? To your linked list first. Basically, you set your cursor, is it? You start your cursor with the first node, is it? Then it's know how to advance. Is it cursor equals cursors next? Is it? So similar concept as our traversing over here, and also has a has next. But this is what your iterator interface needed to do. Is it? It has those three methods, and you need to define a class. Then you explicitly implement the three methods. Then you can go ahead, use this iterator method, okay? So this is our new version of linked list, okay? And then next, let's see the driver part of our linked list. For this driver part, what over here is, we are going to create what? A linked list of the car. Car is a class we just defined, is it? And the first one is going to be the name default, color is default. Okay, that's the first one. Then we call insert after, okay? And we can check what's going to be in our linked list. And we can keep calling insert after. It's we insert after which one? Okay, after the first one, is it? We always do that. And then we can do the check of our linked list. If we have car 1, car 2 to car 5, is it plus that default, okay? And over here, we create a deep copy, is it? So this is the second linked list, okay, deep copy one. And then we also check if both linked lists are the, have the same contents, okay? So that's the one. And then we also check the contain method. Contain is to check if you have some specific item. So here we want to check if we have car 4, is it? If you have it, then you are going to call the remove method, is it? So that's what we do here. After remove, you can check if it item got removed. And then over here, we check the first item called the get function, okay? And the next, let's see. So this is new, okay? And over here, we are going to use the iterator. Okay, so with the iterator interface and the iterator, iterable interface, both of those interfaces implemented here, then we can go ahead and use our iterator to do the loop. So let's see how we explicitly use the iterator to do the loop. And this kind of iterator that we just defined in Java, we call it external iterator, okay? So the way to do it is, this is our linked list, is it? If you call the iterator method, what it will give you, it will basically, it will let you get to the first node, okay, get to your first node. Then you can use a while loop. While, and then you check with this iterator. You call the iterators has next. Okay, if it has next, then you can get what's in the item, and you can also advance the iterator to the next node. Okay, so over here you can see with the provision of the iterator, you can also do the loop. Is it? You can use the iterator to do the loop explicitly. Okay, so that's what over show here. And the next part just show, because we implement of an external iterator that you can use for each loop. And when we use for each loop, basically it's implicitly we use the external iterator. If you don't implement that iterable interface, you cannot use here, okay? And because we implement that iterable interface, that's why over here you can use this for each loop with our linked list, okay? So that's the general idea here. So let's take a look, let's run it and take a look. Yeah, if you take a look, you see it works perfectly. As it has all of the items, and it does remove the specific car, as it, and it does implement insert after, as it, and you can use the iterator to do loop. You can also use for each loop to do the loop. Okay, so so that's basically what we discuss today. So the major information for today is regarding iterable interface and iterator. Okay, so that's an important concept. And I think that's all for today. So do you have any other questions? Is everything good? If everything good, so okay, yeah. So how about you just send the chat your name so that I can keep track of it.